Myself Padmaja, Associate Professor, Department of CSE, Institute of Aeronautical Engineering, Hyderabad. In this video, let us discuss today problem-solving questions on structures and unions. Now, let us start with the definition of structures. So, what is a structure? A structure is a collection of heterogeneous data elements which are having some logical relationships. Now, every element in a structure will have its own memory location, and every element of a structure can be accessed by using the accessing operator, that is either a dot operator or arrow operator. Now, if the structure variable is a simple one, then we will use the dot operator, and if it is a pointer type, then we will use the arrow operator. Now, let us see the example of a structure. So, how to write a structure? So, structure is written using the keyword struct. So, here struct is the keyword, followed by we will write down the name of the structure. Now, every structure will have a number of structure members. So, here character name of 10 and integer age. These two are called the structure members. The structure should be ended with a semicolon. So, here we have written the semicolon, which says that a structure must be terminated by a semicolon. After that, for the structure, we have to create a structure variable. So, here struct student S. So, here S is a structure variable. Now, this structure variable is a simple variable. This is called a simple structure variable. Now, we have done initialization for the structure members here. So, name will be Rama name. Rama will be stored into the name, and 21 will be stored into the age field. Now, if you want to display the content of the content of the structure members, then you have to take the help of dot or arrow operator. Here, the structure variable is a simple structure variable, so we'll use dot operator. So, we'll write down percentile S dot name. So, if you want to access any structure member, then your structure variable dot structure member we have to write. So, structure variable is S dot structure member is name. Similarly, the second member S is the structure variable dot age is the structure member S dot age. So, here you will get the output as Rama, and here you will get the output as 21. So, this way a structure is written. Now, each structure element is accessed through its structure object or structure variable. Now, how to compute the size of a structure? Now, size of a structure is nothing but the sum of the size of all its members. So, size of its logical elements. For example, if this is the student is a structure, these two are the structure members. So, first member is character name of size 10. So, here we have to write size of character is how much? Is 1 byte. And how many bytes we need? We need 10 bytes. So, it is total 10 bytes of space is required. Similarly, what is size of integer? So, size of integer is suppose 4 bytes. So, 4 bytes of space is required. So, totally 10 plus 4, it is 14 bytes is the size of the structure. That means you have to understand, to store the name Rama, we have given 10 bytes 0 to 9, and another 4 bytes is for the age. So, age is suppose 21. So, this is called the name, and this is for the age. So, every structure member will have its own address. Suppose the starting address of this member is 1000, then the ending address will be 1009, and for the age the starting address is 1009, so it will be 1013. Okay. Now, in this way, the size of the structure is computed. Size of the structure is nothing but the sum of size of its individual members. So, here two members are there, name and age. It requires 10 bytes, it requires 4 bytes, total size is 14 bytes. Now, how to access the structure members through pointers? Now, There are two ways to declare the structure variables. One is called a simple structure variable, another is called a structure pointer. Now, let us see, in this case, book is a structure which containing three members. One is called name and author and the pages. Okay. Now, if you will compute what is the size of the structure, if you will find out what is the size of the structure, then the first one is the name, which requires 25 bytes. Because size of each character is 1 byte plus we need 25 bytes. Author is also requiring 25 bytes plus pages is integer which requires 4 bytes. So it is 54 bytes is required for this structure. Now, if you will draw it, then you have to understand from 0 to 24, this is a 24 bytes, we have to store name and another your 25 to this is your 49. So here you have to store the author name and the last 4 bytes you have to store the pages. Okay. Now, how many types of variables you can create? Structure variables are of two types. One is called simple structure variable. Another one is called structure pointer. So here B1 is called a simple structure variable and star PTR is called a structure pointer. So for the same structure, we have initialized the structure members, that name is C programming, author is Balaguruswamy and number of pages is 400. But we want to display the structure members contents using the structure pointer. So first of all, the pointer should point to the structure. So that's why you have to write PTR is equal to ampersand of B1. B1 is the structure variable whose address we will store it into the pointer. That means this pointer PTR indirectly points to the structure. Now through the pointer, we are going to display the name, author and the number of pages. So for that reason, we have to use the arrow operator. So we have to write like this. If you are not using the pointer, if you are using this simple structure variable, then write b1.name, b1.author and b1.age. Okay. But if you are using the pointer, because pointer already contains the address of the structure, then you have to write PTR arrow name, PTR arrow author and PTR arrow age. So only there is a difference in the accessing operator. Here you are using the dot operator and here we are using the arrow operator. So this way the structure members can be accessed through pointers. Now next we will talk about what do you mean by a SlackByte in structures. Now in structure every member will be allocated with its own memory and the memory for the members of the structure is allocated with the word boundaries. Okay. So at certain boundaries which are called word boundaries normally. So in such cases, whenever you are allocating memory for a character, suppose the character requires only 1 byte, then 1 byte is not allocated, it is allocated with some extra bytes. So those extra bytes are padded normally at the end of each member whose size is less than the largest data type, so that the address of each member starts at the word boundary. These extra bytes which are padded are called the SlackBytes. So the extra bytes that are inserted to maintain the boundary requirements are called the SlackBytes. Now let us have one example. Suppose we have one character type and one integer type data member or structure member. So integer type data member requires suppose 4 bytes. So this requires 4 bytes. But if it is a single character variable, suppose it is char ch, so which requires only 1 byte. But to maintain the word boundary, it internally allocates 4 bytes. But the character type variable ch requires only 1 byte. So the remaining 3 bytes which has been already allocated are called SlackBytes, or these are the extra padded bytes to the character type variable. Okay, and these bytes are known as simply the padded bytes or SlackBytes. Next, nesting of structure, that is structure within structure, is called a nested structure. Now nesting of structure is possible and we can declare a structure within another structure, but it is necessary that the inner structure must declare its own structure variables, otherwise we cannot access the members of the inner structure. So that you have to take care. For example, here struct employee. Employee is the outer structure and DOB is another structure. This is called the inner structure. This is the inner structure and this is the outer structure. So employee ID and name, these are the outer structure variable, whereas date, month and year are the inner structure variables. So to access the inner structure members, we need to declare one inner structure variable, that is called DOB is used. That means if you write dob.dd, that means we are going to access the inner structure member. Similarly, dob.mm and dob.yyyy, if you write, then you are accessing the inner structure members. This is called accessing inner structure members. Similarly, if you want to access the but this structure is embedded inside an outer structure. That's why whenever you want to display the details of date, month and your year, then you have to pad it with the outer structure variable. What is the outer structure variable? That emp.dob.dd. Similarly, emp.dob.mm and emp.dob.yyyy. So it indicates that this part is the inner structure and this is the outer structure variable. But if you want to access the employee ID or name, then inner structure variable is not required. That means simply you can access emp.emp_id or you can access emp.emp_name. That means for the inner structure, we have to write outer structure variable dot inner structure variable dot member name. So this is the way you have to write. EMP the outer structure variable, DOB the inner structure variable and DD is the inner structure member. So we have to access the inner structures like this. Now for outer structure, we have to just write the outer structure variable dot member name. Now there is no limit on the levels of nesting. You can nest it up to any level. Now, like structure, we have another special data type called unions. So, union is a special data type which allows storing of different data types in the same memory location. The difference is in structures, every member will have its own memory location, but whereas in union, every member has to share the same memory location. Now, the element which occupies more memory, that will be shared by all the elements of the union. So, a union may contain a number of members. Out of that, any member which requires highest memory, that much memory will be allocated and that has to be shared by all the members of the union. Now, only one element in the union can be initialized at a time. Now, next concept is called bit fill. What is the use of bit fill? Bit fill concept is used in structures where every structure member can be initialized or can be indicated with the number of bits they need. So this concept is generally used to save memory. Now, a structure declarator can have a specified number of bits called the bit fills. So normally the bit fills are interpreted as an integral type. And how to write bit fills? So bit fills are used in structures only. So you have to write down struct followed by a structure name. Then where you have to write type specifier, that is integer or character or float or signed, unsigned, int, anything. Then followed by the name of the field. Field name is nothing but the structure member, colon, the size. Size is in terms of number of bits. Now here, the size specifies the width of the field in bits. For example, if you are writing struct demo, then here you can write unsigned A or unsigned int A is 4 bytes, suppose 4 bytes. Similarly, unsigned integer b is suppose 3 bytes. Like this we can declare. So here demo is nothing but the name of the structure, and this is the type specifier, what type of data, that is unsigned integer. A is the field name and colon number of bits. So if you do not specify, for the unsigned integer normally 4 bytes is allocated. But if you specify that for storing the value into A, we are indicating only 4 bits, okay, not in bytes. So this way it is going to save. So suppose to allocate 4 bits, or suppose I am writing 5 bits over here. Now memory is normally allocated in bytes. So 5 bits means at least 1 byte of space will be allocated to A. Okay, out of that 5 bits will be used and remaining will be unused. But if you do not write the number of bits, then A requires normally 4 bytes. So here, by using the bit field concept, we have saved here 3 bytes of space. So it depends on the value of A, and you know that how much memory is exactly required, because the data values are stored into binary form. So for storing the binary number or binary form of the integer, how much memory is required, that many bits you can specify. But though you are writing in bits, but memory will be allocated in bytes. Suppose if you are writing 5 bits or 6 bits, then 1 byte minimum space is allocated. Now, so the size what you are specifying is nothing but the width of the field in bits, and the type specifier for the field name must be of unsigned integer or signed integer or integer. Now the size must be a non-negative integer value over here. So it must be a positive integer value. Now in bit field concept, array of bit fields or pointer to bit fields or function returning bit field concepts are not allowed in C language. So only bit field is a concept which is used for each structure member so that memory can be saved. And bit fields cannot be declared as a part of the structure. It has to be written for every member. Now the address operator, that is the ampersand, cannot be applied to bit field components. Similarly, the unnamed bit fields cannot be referenced, and their contents at runtime are unpredictable. So they can be used as simply dummy fields for alignment purposes. So please keep this in mind, that the unnamed bit fields are simply used as your dummy fields. Now let us move to our Deb C++ compiler and execute a number of programs related to structures, unions and bit fields. Now let us start with a structure program. Hash include stdio.h. Now let us first understand how to access a structure using a simple structure variable and a structure pointer. So accessing the members of the structure using dot and arrow operator. Int main and return 0. Let us declare a structure struct employee. Now this structure is containing some members: character, name of, size 10 and integer age. Okay. Now let us close the structure here with a semicolon. Now let us create two types of struct variable. So one is called simple structure variable is E, and which is equal to, let us do initialization for the structure. So initialization for name, so let us say Rama is the name and age is 25. Now let us declare one structure pointer, struct emb star ptr. Now through this pointer also we want to access the members of the structure. So for that reason, first of all you have to store the address of E into the pointer. Address of the structure variable into the pointer. Now print the content. So let us write how many members are there. First one is %s, then %d. And you have to write e dot name and e dot age. Now the same thing if you want to write using structure pointer, then you have to write like this: %s space %d. Here you have to write ptr arrow name and ptr arrow age. Okay, now let us save this program and run it. So compile and run. Now you can see here, in both ways of printing using simple structure variable and the structure pointer, we are getting the same output Rama 25. So this is about how to access the members of the structure using the dot and arrow operator. Now let us move on to another example where we will talk about the SlackBytes. So the concept is SlackBytes in structures. Now let us take a structure called demo and take one character variable ch and one integer variable a number n. Now for this structure demo, d is the structure variable. Let us store one character a and one number, let us say 100. Now let us find out the size of the structure. So let us write down size of the structure is equal to %d. Let us use the size of operator, size of d. Right? Okay. Similarly, let us find out the size of each member. So let us write like this: size of ch structure member is equal to %d, comma. We have to write down size of how to access ch. So you need d dot ch. So put a semicolon, and in the similar manner we have to print the size of n. N is the structure member, so size of d dot n. Right. So save the program as .c file and run the program. Now here bracket is missing, so let us give the closing bracket, save it and compile it again. Yes. So what is the size of the structure? Is 8 bytes. But theoretically you can see that ch requires only 1 byte and n requires only 4 bytes. So it should be 5. So if you will see the size of ch structure member, it is only 1 byte, and n is the another structure member which requires only 4 bytes. That means 4 plus 5 should be 4 plus 1 should be 5 bytes. But the size of the structure is 8 bytes because it is doing padding the extra bytes into the ch. To maintain the word boundaries, it is making 4 bytes. So in this way, the total size of the structure is 8 bytes. This is called the SlackByte concept. Now, after understanding the concept of SlackBytes, let us understand another program on nested structures. Nested structure or nested structures. Let us write down #include stdio.h int main struct world. Now, in this structure, we have one integer variable, one character variable, and there is inner structure, struct India. Now, in this, we have another character variable and we have a float variable D. Now, for the inner structure variable, let us declare the variable I, and for the outer structure variable, the variable is W. So, here I is the inner structure variable and here W is outer structure variable. Right. Now, let us do the operations. So, write struct world, or if you will omit here W, you can write here. Okay. So, struct world W is equal to, so what are the members are there? How many members are there? One integer. Okay. Followed by one character is there. Then followed by another character is there. Then followed by one float value is there. Let us say 1.8. Right. So, we have initialized the values for the structure members. Now, let us print it. So, printf, all the members we want to print it. The first member is integer, so percentile D, space. Second member is character. Then third member is again a character. Fourth member is float, so percentile F. Now, what are the, how to access the members? So, A and B are in the outer structure. So, what you have to write? W.A, W.B. But C and D are in the inner structure. So, what you have to write? W.I, outer structure variable, dot inner structure variable, dot C, W.I.D. You have to create like this. Okay. So, this way we need to print the content. Now, we have written one outer structure and one inner structure. So, return 0 and let us save the program. Save the program as a .c file and run it. Now, you can see here that we have clearly extracted or displayed the values of outer structure and inner structure 1, A, B and 1.8. So, you can see that after 1.8, your precision is up to 6 decimal places in float. So, 1.850 you are getting. So, this way the members can be accessed. So, this is the example regarding the nested structure. Now, let us go for an example of an union. So, the concept is union. Hash include stdio.h, int main and return 0. Now, in this, let us create one union. Let us union A, and this union is having one integer member and one character member, ch of size 2. Now, here, what is the size of integer is 4 bytes. Size of a character is 1 byte, but you are asking for size is 2, so total 2 bytes. So, let me write over here. So, this is 4 bytes memory requirement for this variable. For this variable, the memory requirement is 2 bytes. Now, let us create one union variable, union A, U. A is the name of the union and U is the union variable. Now, U dot ch of 0. You want to store a number, or let us say you store a character, and U dot ch of 1. You want to store another character B. Similarly, if you want to store any value into I, so you can write U dot I is equal to 10. Now, let us display the value of all these members. So, percentile D, then your percentile C, followed by U dot I, comma, U dot CH of 0, comma, U dot CH of 1. Okay. Now, if you will change this union to structure, then what will happen? Or if you are using a union concept, then what will be the output? Let us understand. First, save the program as union 1 or union 2 dot C source file and save it. Let us compile and run. Now you can see here all the members of the union are initialized, but in union only one member can be initialized at a time. So one member is initialized at a time. So the first member is initialized with the value 10. Now if I will put this into comment line, then what will be the output? So you can see here that the first one is not initialized. So some garbage is coming, and the second member is initialized with some values. So you are getting the values of A and B. So this is one union example. Now let us go for example of bit field. Write down hash include stdio.h int main and return 0. Now unsigned ints, let us write short integer, short a, colon, number of bits we are allocating is 4. Similarly, let us declare a structure first, struct struct, and bit field or my bit field, for example. Name of the structure is my bit field, and inside this declare these members. Now second member unsigned short b is 5 bits and unsigned short c is 7 bits, right? Now for this bit field, let us create a variable called test for this structure. Now assign some values. Test.a is equal to 2. Similarly, test.b is equal to 31 and test.c is equal to 0. Now display these values. Write down printf percentile d and percentile d. Write down test.a, comma, test.b, comma, test.c. Now, if you will save and run this program, it is related to bit field. Save it as a .c file. Now, run this program. You can see here the output is your 4 bits is enough to store 2 because the binary equivalent for 2 is 10 and for 31 5 bits is required, and for 0, okay, anyway 1 bit is enough. So we have given 7 bits. So the memory allocation will be 1 byte here for A, 1 byte for B and 1 byte for C. So instead of allocating your short integers are 2 bytes. So 2 into 2 into 2, it is 6 bytes. Instead of 6 bytes, only 3 bytes is enough for doing this program or for storing these values and displaying it. So this is called the concept of bit fields. Now let us move on to another program related to structures. Find the output of the code. hash include stdio.h int main and return 0. Let us declare a structure struct A, and this structure is having two members, one integer member and one character member, character J. And this structure is having two types of variable, one is A and another one is star P. Now, let us store some values into the structure members. So, A.I is equal to some 5 and A.J is equal to some character, let us say A. So, we have stored one character and one integer into the members. Now, let us write P is equal to ampersand of A. That is the address of the structure we are storing into the pointer. So, P is here a structure pointer. Structure pointer, which stores the address of the structure. Now, if you will write printf %d space %c /n, print the values as a.I, a.j. Similarly, if you want to print it using the structure pointer, so %d space %c, then you have to write your p arrow, your I, p arrow j. Now, save this program and run it. Save your file and then compile and run. So, you can see here, in both the cases, you are getting the same values 5 and 5a. Now, this is about the structure example. Now, let us go for finding the size of the structure. Let us go for another program. Find the size of the structure. Hash include stdio.h int main and return 0. Let us declare a structure struct A, which contains two members, integer roll number and character name of 20, and declare a variable s as the structure variable. Now, store one value for roll number is equal to suppose 501 and store one name using the string copy function, as the member is a character type or a string type, so you have to store like this. So, which is nothing but s dot name, comma, we are storing the string as Rama. Now, if you will print the values, so you have to write percentile d space percentile s, then give a /n. So, you have to write here s dot roll number, comma, s dot name. This is for displaying the content of the structure members. Similarly, if you want to print the size of the structure is equal to percentile d, that is the memory requirement for the structure, so which is nothing but the size of the structure variable s. So, this way you can compute the size of the structure. Now, let us save it and go for compilation and running the program. So, when you will compile it, you will see that when you run the program, there is no compilation error. So, for strcpy, you are getting incompatible implicit declaration because we have not returned string.h header file. So, if you will write, then the error will go. So, size of the structure is 20 plus 4, integer requires 4 bytes and name of 20 is 20 bytes total, 24 bytes. And the name is 501 Ram. So this way the program will give you the correct output. So here let us include #include string.h. Save it and run it. Now you can see that there is no compilation error and you are getting the same output. Size of the structure is 24 bytes and the value stored is 501 and RAM. In this video, we have learned the concepts of structures, unions and bit fields, and also we have executed a number of programs related to these concepts. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.